Okay, group 3. A baseball is thrown horizontally at 25 meters per second from a 60-meter high bridge. How much time until the ball hits the water? So let's think about all the things that we know right now. We know it's thrown horizontally, and this is the velocity. Since it's thrown horizontally, that means that the initial velocity equals the horizontal velocity. There is no initial vertical velocity, okay? And it's thrown from a bridge that is 60 meters tall, so this is our distance in the y direction. Okay, so how much time until the ball hits the water? I'm going to go ahead and set up my data table so that I've got all of the pieces that I need, and I can add them along the way. So we might have delta x, we might have velocity in the x direction, we might have time, we might have delta y, we might have initial vertical velocity, we might have final vertical velocity, acceleration, and time. Okay, and we can fill in some of these things already. From our problem, we know this is our horizontal velocity, or our Vx. So that's 25. We know our distance in the y direction is 60. Since it's thrown horizontally, all of our initial velocity is horizontal, so VIY is 0, and acceleration is 10. Okay, so the first question says, how much time until the ball hits the water? So we're coming to our formula sheet. We're going to focus in on the side that talks about projectiles, and I'm going to look for one that will help me to solve for time when I know distance and I know acceleration. And so when I check that out, I would choose this one right here. T equals the square root of 2 distance in the y direction divided by g, which is the same thing as a in this case, because a is the acceleration due to gravity. Actually this, but we're going to use 10. So I'm going to pull that equation in. So t equals the square root of 2 times the distance in the y direction divided by acceleration due to gravity, where t equals the square root of 2 times 60 divided by 10. So that's 120 divided by 10, which gives me t equals the square root of 12. Now, some people have a tendency to stop here. That's not the end. We have to do the square root of that. So t equals T equals 3.46 seconds. Okay, so that's my time here, which means that's my time here. So now we're asking, what is the range or the distance traveled in the x direction of the ball? So in the x direction, that's another word for range, so I'm looking for delta x. And so I come back to my formula sheet and I check it out. So the distance in the x direction, or the delta x, equals the velocity in the x direction multiplied by time. Okay, so I'm going to come back to my data table and I'm going to fill in values. So I don't know what delta x is, but I know that the velocity in the x direction is 25, and I know that the time is 3.46 seconds. And so when I multiply those together, the distance in the x direction is 86.5 meters. Okay. So let's think about 3 things that we could change, that could change to make this in the scenario that would increase the range, that would make this number get bigger. So the easiest place to think about that is to just look at this equation. If I want this number to get bigger, what could I do to this number that would make this number get bigger? Well, I could increase my horizontal velocity. Right? I could throw it harder so that it's going to go faster. Time. What could I do that would change the amount of time that the ball has to fly? Well, the only way to change time is to change the height from which it is falling, right? Or the maximum height that it reaches. So what I could do is I could increase the distance in the y direction, right? We could go to a bridge that's even taller, and that would mean that it would actually fly for longer, which would make it go farther. The other thing that we could do is to throw it at an upward angle. Okay, If you throw something at an upward angle, it's going to make it go high into the sky, which is going to increase the time versus throwing something, right? If I throw something horizontally, then it makes a path like this. So where the height that it's thrown from is the maximum height. But if you throw something at an angle, right, it's starting from a height down here, and it's going to reach a maximum height here. So by adding an angle, it's going to have that time to go up to the top and fall back down again.